Dr. Stephen O'Brien's next step is to try and find a group of people who are directly descended from plague survivors. If the theory is correct, tests will show that a high number of them are Delta 32 carriers. The challenge is tracking these people down. In the centuries since the Great Plague, London has changed immeasurably.
Because there's a lot of migration in human populations in and out of London, you're going to get other genes coming in and genes going out from the gene flow.
Very few people in today's London can trace their ancestors back as far as the time of the Great Plague. And that is a major block to Dr. O'Brien's success. If he's going to demonstrate the power of Delta 32, he has to find a community where people can trace their ancestry right back.
We were looking for a town which had been succumbed to the disease, but which had not really changed much in terms of immigration of people in and out. A time capsule, if you will, of the survivors of the actual event.
And after years of searching, he found one. 120 miles north of London, deep in the valleys of England's Peak District, lies the small village of Eyam. 3 centuries ago, the plague hit Eyam and is still remembered today. It came on the 9th of August, 1665. To the south, Londoners were dying in their thousands, but so far Eyam had been spared. What the villagers didn't know was that a biological time bomb was about to be planted among them. A traveling salesman named George Vickers arrived from the capital. He had come to sell bales of cloth. Needing a bed for a few nights, he was welcomed into the home of the Cooper family.
Mary Cooper.
For days, everything seemed normal. Vickers went from house to house, selling cloth and tailoring clothes. But on the night of the 2nd of September, Mary Cooper heard her house guests screaming. Vickers had a fever. He was vomiting blood and bleeding from the nose. 5 days later, he was dead. And he was just the first. 10 days later, Mary Cooper's infant son died. The villagers realized what was happening. The parish priest called a meeting. As more and more people became sick, the healthy gathered together. They made a decision of tremendous courage. In the full knowledge that they might be sentencing themselves to death, they decided to place the village in quarantine.
It's all around us. It's all around us.
No one would try to run. No one would leave or enter Eyam until the epidemic had run its course.
In an incredible gesture of self-sacrifice, the population of Eyam sealed off the village in order to stop the plague spreading further. So what we have is a very small, tightly knit community, which remains a tightly knit community to this day, where they were completely able to control people coming in and out of the village.
For Dr. Stephen O'Brien, this event has huge scientific importance. While many small towns suffered the plague, the story of what Eyam went through has been meticulously recorded. Not only that, but many of the people living there could trace their roots all the way back to the 1665 outbreak. For Dr. O'Brien's purposes, Eyam is perfect.
When I first learned about Eyam, where most of the people that lived there were descended from the survivors directly, I became very fascinated with what I perceived as a scientific opportunity.
Every year, the descendants of the plague survivors take part in a procession to keep alive the memory of their ancestors' bravery. Joan Plant is one of them.
I first heard that we were related when we put together this family tree and traced it back to Margaret Blackwell, who was a famous heroine, if you like, in the plague.
Margaret Blackwell's story has become part of Eames folklore. She had lost 5 members of her family when she herself fell ill. It is said that one day she staggered from her sickbed, entered the kitchen of her home, and either out of delirium, thinking it was water, or out of desperation, thinking it would end her life more quickly, she drank a jug of hot bacon fat. She vomited and collapsed. But then, somehow, she began to get well. She recovered.
I asked Joan if she believed that the bacon fat had actually saved Margaret Blackwell, and she said she thought it probably did. And I told Joan I thought I had a different idea.
Dr. O'Brien believes that Margaret Blackwell was one of the lucky ones, that she had inherited Delta 32 from both her parents, and it had saved her life. If he's right, if the mutation did save her and the other survivors, many of their descendants should carry it. Will O'Brien get his proof? Is the ability to fight off killer infections actually being handed down from generation to generation? And is it possible to harness this power in our own modern battle with infectious disease? The evidence is starting to point towards a genetic link between immunity to bubonic plague and immunity to the HIV virus. If Dr. O'Brien is right, a higher than average percentage of these people should carry the Delta 32 mutation. His plan is to take and analyze samples of their DNA.
And then we take this back to the laboratory where DNA is extracted that is suitable for analysis of any genes we might be interested in or you might give us permission to test.
The DNA of each volunteer is analyzed for the presence of Delta 32. The results seem to confirm Dr. O'Brien's theory.
Yesterday, looking for Delta 32 in that sample we collected from Ian. We actually collected something like 85 individuals to see who had Delta 32, who had 2 copies, who had 1 copy. And when we genotyped them, we discovered about 15% of them were Delta 32 from EM, which is about 50% higher than the surrounding regions around EM, which had not had the same history of plague. So that was exciting, and the number of people that had 2 copies was twice as high as we expected.
Although the evidence so far suggests that Delta 32 carriers are immune to bubonic plague, O'Brien needs proof. He's about to perform the test all his research has been leading up to. Under laboratory conditions, the cells have been exposed to the plague bacteria, Yersinia pestis, and the results are extraordinary. Delta 32 does appear to offer immunity.
If you take normal cells that have the normal parent molecule of Delta 32, a gene we call CCR5, they do take up Yersinia pestis quite rapidly. If you take cells which have the equivalent of Delta 32, they're resistant to Yersinia pestis. They do not take it up.
After years of research, Dr. Stephen O'Brien and his colleagues finally appear to have their answer. Delta 32 really does seem to be an almost miraculous mutation. It protected people from bubonic plague for centuries in Europe. And carried by their descendants, it has also helped defend against the modern plague of HIV/AIDS. Now that scientists understand how Delta 32 works and where it comes from, they are beginning to learn how to mimic its effects.
So if we could discover why patient A fights off AIDS or Ebola or SARS or bird flu and patient B doesn't, then we could imitate the process by developing new pills or therapies or drugs that we can give to the patient who wasn't lucky enough to be born with them.
This new generation of medicines is already being tested. Spike Rhodes has been HIV positive for 20 years. He was close to death when he was given the chance to try the first in a new class of drugs called fusion inhibitors. Just like Delta 32, they stop the virus by blocking the portal through which it enters cells. For Spike, the results have been extremely encouraging. The T cells, which support his immune system, began to recover within weeks of first taking the drug.
My T cell counts had doubled, and my viral load had gone undetectable, which was also quite a surprise. And within the next 3 months after that, my viral load stayed undetectable, my T cells had doubled up again. If it hadn't come into my life, I probably wouldn't be here.
AIDS, SARS, leukemia, prostate cancer, breast cancer, Alzheimer's, Parkinson's, the litany of diseases that fill our hospitals. Discovering how these defenses work explicitly, pinpointing the exact gene, giving us a mechanism, well, then we know what to go after. Then we know how to develop treatments that are effective and clear out these hospitals from these chronic diseases that we cannot treat.
We are in the middle of a scientific revolution that could change the way we treat sickness. It's a revolution that began in death and suffering centuries ago. And as threats continue to emerge from all corners of the biological world, it may be the mysteries and miracles of the human body itself that provide our ultimate line of defense.